Okay, so Junior Roberts here with realjuniorroberts.com. We're on to a CSEC past paper question, right? This is related to lenses, right? So let's go right into it. So it says here, Keshawn investigated the relationship between image size I and the object size O while studying shadows. His results are presented in table 1. And here we have table 1 with our data showing the image size. Image size varies with object size, right? And we see that image size goes from 2.5 centimeters up to 15. Similarly, the object size goes from 0.5 centimeters up to 3 centimeters. Now, it says here the first thing we're required to do is on page 3, plot a graph of image size I versus object size O. So in this case, right, we're plotting image size here against object size. So therefore, we know that whatever will come first in our statement here will go on our y-axis. Right, so therefore the image size will go on the y-axis while the object size will go on the x-axis. Right, so we're going to put image size on the y-axis and object size on the x-axis. So let's go to our graph paper and we can now plot our graph. So here's our graph paper. I went ahead and ruled up my graph paper, labeling my x-axis and my y-axis, and I put in scales for both axes. Now for the x-axis, right, I'm using a scale of 2 centimeters equal 0.5 centimeter. So for each 2 centimeters, I'm incrementing by 0.5 centimeter, right? And on the x-axis, right, it said we are to plot object size, right? So we can make a note of that. So we're saying that we're plotting object size, right? That's O in centimeters, right? Now for our y-axis, right, first of all, let's state our scale. So for the y-axis, I'm using a scale of 2 centimeters equal 2 centimeter. So for each 2 centimeters, I'm incrementing by 2 centimeters. And on the y-axis, right, I'm plotting image size, right, that this is I in centimeters. So I have my two axes fully labeled, so I can begin by plotting my points. So if we look back at our table, right, we see that whenever our image size is 2.5, our object size is 0.5. So we're going to find these points and plot this point. So we're going to go to our graph paper, right, 2.5 to 0.5, right? So we have 2 right here. Here would be 3. So halfway in here would be 2.5, and that corresponds to 0.5. So we're going to plot this point right here. So we're going to use a dot with a circle. Right, our next point, we have 5 corresponding to 1.0. So we have 6 right here, 4. So 5 will be right here, and that corresponds to 1.0. So it's going to be right here. And we circle. Right, now if we continue, we see we have 7.6 corresponding to 1.5. So we can find that in our graph. So we have 7 right here, 7.2, 4, 6. 7.6 is right here and corresponds to 1.5. So 2, 4, 6. And we circle. Now we can continue. Right, so we have 10 corresponding to 2.0. So we have 10 right here corresponding to 2.0. So it's going to be right here. Then we will continue. And we have 12.6 corresponding to 2.5. So 12 is right here. 12.246. So we'll go right there. and we circle, and it corresponds to 2.5 here. Now our final point is when we have 15 corresponding to 3, so we're going to find that. So we have 14 right here, so 15 will be right here, and it corresponds to 3.0. So we have 14 and then 15 right here, so we're going to place our dot and we circle. Okay, so it turns out that this point should be a bit down because it should correspond to 7.6. So 7.6, this is 7, so 7.6 would be right here. Right? So that's my point. Now I'm seeing where the points are lining up quite nicely. So I should get a very nice looking best fit straight line. So I'm going to try again for my best fit straight line. So I line up, and let me just go like this and line up. Alright, so I'm getting a very nice looking best fit straight line. Right, so this is my best fit straight line. Right, and it actually passes through almost all the points. Right, so I'm going to draw this as my best fit straight line. Right, so that's my best fit straight line. Now I will place my title in. Right, and I will say graph showing whatever is on the y-axis versus what's on the x-axis. So now we have completed our graph. Right, so this is our graph completed. Now let us see what else they want us to do. So the next thing they say we need to do is to calculate the gradient g of the line obtained. So they say we need to find the gradient, so let's work on doing that right now. So we know that the gradient, right, g will be equal to y2 minus y1 divided by x2 minus x1. Now, for us to find our gradient, we have to select 2 points on our best fit straight line that are far apart but are not in the table. In other words, there weren't any of these points that were plotted. So, in this case, I'm going to choose my 2 points. I'm going to choose a point here. Right, and I'm also going to choose a point about right here. I'm going to choose a point here. So these are my 2 points that I've selected. Now I will just get the coordinates by drawing broken lines from the points to each axis. So let me do that right now. Alright, so I've now drawn my broken lines, so I can now simply obtain values for, in this case, x2 and y2 from this point, and x1 and y1 from this point. So here I'm seeing that my y2 value is 18 from this point right here, and from this point my y1 is 2. So I'm going to just fill those in. So I will say y2 is 18 centimeters minus y1, which was 2 centimeters, and that is being divided by x2 minus x1. So let's get our values for x2 and x1. So our x2 value is 3.6, because each of these single line is 0.05. So we're going to get 3.6 right here. So 2 double lines will be equal to 0.1. So we have 3.55, 3.6, 3.65, 3.7, 3.75, all the way up to 4.0. So this line right here is 3.6, right, while this one here is 0.1, 0.2, 0.3, 0.4 is 0.4. So we'll say 3.6 centimeters minus 0.4 centimeters. So now we'll simply do our math, right, and we're going to see that when we take the difference of this, we're going to get 16 divided by 3.2. Now when we take the quotient of this, we get, right, so we say 16 divided by 3.2, and we get 5, right? In this case, because we have centimeters in our numerator and centimeters in our denominator, we will not have a unit for our gradient, right? So this is the value for our gradient, G. Now let us continue. So it says now, state the physical quantity with which the gradient of the graph G is associated. So because we plotted image size versus object size, the gradient of this graph will represent the magnification, right? Because you can remember that our magnification M is equal to the image size over the object size. So since our graph is the image size plotted against the object size, once we find the gradient of this graph, we will get the magnification. So we'll say that the gradient represents the magnification of the lens, right? So the gradient represents the magnification of our lens, and we'll continue, right? So it says now, during the investigation, Kishorn talked with his friend Atiba about the term focal length. Define the term focal length. So we'll say now that the focal length, so we'll say the focal length is the distance from the optical center of the lens to the principal focus, or focal point. Right, so the focal length is merely the distance from the center of the lens, which is the optical center, to the principal focus or the focal point. Now, next question says, with which piece of apparatus in physics is the term focal length associated with? Right, and we're going to say that this apparatus is a lens. Is the lens. So once we talk about focal length, we're dealing with a lens. So our next question says, a 10 centimeter tall tablet computer was placed vertically 20 centimeters from a plane mirror. Its image distance was found to be 20 centimeters. And now it says, use the data given to calculate the height of the image of the computer. So for this, we'll have to consider our plane mirror, right, which is the device that we're using in this case, as well as we have to consider the tablet computer, right? So we have to consider the height of the tablet computer, which is 10 centimeters in this case. We have to consider its distance from the plane mirror, which is the object distance, and we also have to consider its distance behind the mirror, which is the image distance. So to do this, to calculate the height of the image of the computer, we're going to consider the ratio in which we say object distance over image distance is equal to object height over image height, right? So in this case, we have object distance, which is the distance from the plane mirror. In this case, that's 20 centimeters divided by the image distance. Image in this case is 20 centimeters, so we're going to have 20 centimeters, and that will be equal to our object height In this case, our object height is 10 centimeters, so we have 10 centimeters divided by our image height, which is what we're trying to find. So we'll just put V, right, which is for our image height. Then now we can simplify this by simply cross multiplying. So we'll cross multiply and we'll get that V. When we cross multiply, we're going to get V times 20 centimeters is equal to, because we cross multiply here, so the V multiplies 20 centimeters and then 10 centimeters multiplies, well, 20 centimeters multiply 10 centimeters, so we're going to get 20 cm times 10 cm. Right? Now we can simplify this, and when we do so, we're going to get that V is equal to 20 centimeter times 10 centimeter divided by 20 centimeter. So therefore, if we plug this in our calculator, 20 times 10 is 200. 200 divided by 20 is 10 centimeters. So we'll get that our image height, V, in this case, will be equal to 10 centimeter. Right, and we expect this to be the same as our object height because we're dealing with a plane mirror. Right, and we know that for a plane mirror, the object distance is equal to the image distance and the object height is equal to the image height. Alright, so this would be our final answer. So now let's continue. So it says here now we're to calculate the magnification of this image. So to calculate the magnification, we will say magnification M is equal to image height, right, which is V divided by object height, in this case U. Right, so we were told that the image height, we just calculate our image height and it was 10 centimeters, and we were told from before that the object height is also 10 centimeters. So we'll have divided by 10 centimeter, and when we simplify this, we're going to get 10 divided by 10 is equal to 1. And in this case, since we're dealing with magnification, we won't have a unit. Now again, we're dealing with a plane mirror, so we expect the magnification to be 1. Since we said before that the image height, which is what we calculated right here, is equal to the object height, and the image distance, which is 20 centimeters here, is also equal to the object distance. So again, this was Junior Roberts with realjuniorroberts.com. If there was anything in this video that you wish to get further clarification on, then post it below in comments and I'll do my best to clear up any misconceptions for you. Like this video if it was helpful and click subscribe and the bell notification so you'll be updated whenever I post new videos like this. Also, if you're preparing for exams in January or June, send me an email and I will share with you a complete revision guide to help you to prepare for your exams. Thank you for watching.